package, but mostly you have to purchase them. Solidworks Viewer is a free viewer which is available. It can open part file, drawing file, and assembly file. You can just review the file. You cannot edit it. It is available free of cost on their website. Any questions so far? SolidWorks supports many different types of the files. This is a screen print of the files which you can directly open with SolidWorks. You can see CATIA files you can open, Pro Engineer files you can open, part files you can open, step IGS, and many other files you can directly open with SolidWorks. And also you can directly save the file in almost all of these formats without any third-party translator. So this is very useful. Directly you have CATIA file, you can open directly within the SolidWorks and can start working on that. This is a photo view 360 degree. This watch is created in SolidWorks. And I just want to show you, look how realistic it looks like. This is the rendered image. It is very difficult to distinguish whether it is real or not, but this is simply a model. SolidWorks is feature-based. I'm sure you have heard this term very often. What is feature? A feature is defined as smallest building block that can be modified individually. In SolidWorks, solid models are created by integrating a large number of these features. The beauty of feature is features can be added at any stage. Feature can be deleted at any stage. Feature order can be modified any stage. And most important, feature parameters. They can be changed at any stage. That is the beauty of feature-based. All the features which you have used in the software, they appear under Feature Manager, which is basically a history tree. It keeps the record of all your features. A typical SolidWorks Feature Manager is shown here. The features, it has all the features. So SolidWorks is feature-based. Feature-based means a history tree will always be available. Then parametric modeling. SolidWorks is parametric. In parametric modeling, design intent is captured using features and constraints. And this allows the users to automate repetitive tasks. Another definition of the parametric modeling is that software uses standard properties or parameters in defining the shape and size of a geometry. Consider this part. A housing, pipe housing has been shown here. Look on the top face, there are 6 different holes. Due to some reason, we need to change the diameter and number of these holes. If it is parametric, you just edit one hole, change its diameter, and all the 6 holes will be updated. There is no need to do individually. Same is here on the front face and on the bottom face. You just need to edit one holes, and all other instances will be updated at the same time. That is parametric modeling. One example of parametric modeling. Bi-directional associativity. Earlier software packages, they had unidirectional associativity. What do I mean is, Unidirectional means you can only made any change in the model. If we have changed the model, you need to create drawings separately. It was time consuming. SolidWorks, with its first version, it has bidirectional associativity. Means you make any change in the drawing, this change will be reflected in the model. Or if you make any change in the model, this change will be reflected in the drawing in real time. This is very useful. Let's say you are working as a team on a different model. So if any change is made by any user, it will be updated in all the instances where it is being opened in real time. SolidWorks assembly module or SolidWorks assembly can be used to assemble different components using constraint. SolidWorks itself does not use the word constraint. It uses the word mate. As with other software CAD packages, there are two different types of design assembly approaches, bottom-up and top-down. Both are popular. In bottom-up, you design individual component first, and then open assembly file. First, you call one component, second component, make assembly, third component, make assembly. In top-down, you directly start with an assembly file. Within the assembly file, you design first component. First component is there, then you design second component and make an assembly. Then third component is designed and assembled. Both techniques have their own advantages. It is up to the user, whatever he likes it. Most important, you can combine both approaches in order to gain maximum productivity. In bottom-up, because you are working at any time on a single part, so you can give full concentration to the individual part. Once all the parts are modeled, then you can start assembly. On top-down, because you are working directly from the assembly, so your whole focus will be on assembly. As I mentioned, both techniques can be combined and both are popular. Now the most important, certifications. Though you can use the SolidWorks without any certification, but in case if you are looking for an employment, or let's say you are going to work freelance, then certification definitely will increase your chances of getting a better job. In total, SolidWorks offers 17 different kinds of certifications. The exam for certification is done online. You just submit the fees and you can attend the exam. There are 4 different levels of certifications. The entry level certification is known as associate level. Then the professional level, professional advanced, and expert level. These are 4 different levels. So this diagram will give you a clear idea about the certification. CSWA, Certified SolidWorks Associate. This is the most commonly or most popular exam which is administered by SolidWorks. Then Certified SolidWorks Associate Electrical, Sustainability, Additive Manufacturing and Simulations. These 5 certificates are associate level. The fee for associate exam is $99 or £99. After associate level, you can take the professional exam. There are 4 different professional exams. So once you have taken the professional exam, you can go with the professional advanced exam. The first one is Certified Solidworks Associate Sheet Metal, SM for sheet metal. Then Weld Marked, WD. Surfacing, SU. Mold Making, MM. And Design and Tolerance. So these are a professional advance. Or you can just go with the expert exam, which cover all these 5 exams. That is the expert level. As I mentioned, for associate exam, the fee is $99. Professional exam is also $99. And this individual exam, their fees is $20 each. If you want directly to go with the all exam, expert level exam, its fees is $149 US. As I mentioned, there is no such requirement. You can use the SolidWorks without exam, but if you have taken the certification, it will increase your chance of getting employment or getting freelance work. The exams are conducted online, and they conduct many exams in any year. So it is up to you. You can go for it whenever you feel comfortable. Just to give you an idea, up to financial year 2017, 800 million euro. That was the revenue of the SolidWorks, and it has increased now. Now, how you can access the software? Recently, SolidWorks introduced cloud-based. So you just need to go mysolidworks.com, create an account, and you can use their online product. But for online product, your internet connection should be very stable. I tried, but honestly, I am not impressed with it. Maybe because my internet connection sometimes it is not stable. Then comes standalone professional license. Its annual fees is around $4,000 US. It's the same fee when the first version was released in 1995. They have not changed it. So this is the most popular standalone professional version. In addition, if you need annual subscription, that is charged separately, around 1,200, around $1,300 US annual charges. Now you are a student. I understand students have limited budget. For students, the use of SolidWorks is free if your university or college is registered with SolidWorks. In case if it is not registered, then you can consider purchasing of the student license. Its charges very reasonable, $99 US or 99 pound. So these are 3 different ways you can access the software. Cloud-based, most professional user, freelance user, they use this professional license. For students, these are 2 options. Any question, students? Any question? If you have any question.
I have.
Yes, please.
Doctor, does our university have SolidWorks registration or not?
10 years before, we were using SolidWorks. 10 years before. Until 2011, we used SolidWorks. Then we switched to CATIA. And then we switched to NX. So my understanding is, yes, our university is still in their record, is still registered. This is my understanding, but I didn't check it.
So, Doctor, why is the reason of changing from SolidWorks to CATIA, then ending up with NX?
Yeah, let me explain it. SolidWorks is owned by Dassault System. CATIA is also owned by Dassault System. These are two products from the same organization. SolidWorks is basically lower end. CATIA is high-end package. The annual fee for SolidWorks is just $4,000 US, while for single license of CATIA, it is 4 times around 18,000. CATIA has more capabilities. It has more features as compared to the SolidWorks. Our university did the survey at that time. So here in UAE, CATIA was more popular. We were collaborating with Strata. They were using CATIA. So they sponsored CATIA and we decided to go with CATIA. That is the first reason we switched from SolidWorks to CATIA in order to address the market demand. Then in 2018, because CATIA was popular in the UAE, Siemens saw this, that CATIA is capturing the Middle East market. With CATIA, every year we pay license fee, educational license fee. Every year we have to renew the license and we pay the fee. NX offered us a 5-year free of cost their license for educational purpose. No cost was associated. And NX has the same capabilities as CATIA. So this was another opportunity. The university decided to go with NX. It was win-win for both for NX and both for university. The students who will graduate from the university, because they have worked on NX, they will go with, they will take NX with them wherever they go. So that is the reason we further switch to NX. I hope I answered your question. The good thing is, if you have worked on any one package, let's say you have worked on CATIA, you can switch easily to SolidWorks or NX. You just need a couple of hours and you can switch. The basics are same in all the packages. Yes, is it clear?
Yes, Doctor, thank you.
You're welcome. Now I am going to software graphical user interface. Some of you who have used CATIA or NX, it has the similar interface. On the left-hand side, there is a feature tree. Tabs are there. Graphical area is here. Tryout is, you can see on the lower left corner. Heads up toolbar is here. Just like NX and CATIA, heads up toolbar is here. Task pane is on right hand side. And most important, changing of unit is just a click. It is located on bottom left side. Previously, I mean, it was a headache. You start the software, then you realize, oh, you didn't change the unit. And you need to go to the settings. Nobody like that. So that's the reason they bring it here. Settings are here. If you go to this setting, all the software settings are here. One nice feature of SolidWorks is auto recover or auto save. This feature is available also in CATIA, but unfortunately it is not available in NX. You just need to set the time that after 5 minutes, It will give you the reminder 1 minute, 2 minutes, whatever that you need to save your work. Or it can auto recover. You just need to set the time. This option is very useful, particularly during the exam. Because if for any reason, if the system crashes, let's say you have set the recovery time 5 minutes, so your work will not be lost. You can recover easily. But unfortunately, NX, this option is not available. In CATIA, yes, similar option is available, but NX is lacking this. First, I thought to go with a complex part, but then I realized you might lose interest. So I decided to go with the simple part, which I start with my first modeling exercise, the camera body. I will go with it, whether you have used NX or CATIA, just see how much similar is working with SolidWorks, the same thing. We'll make this part first, then we'll create its drawings. I will explain in the drawing, these are a couple of things. I was creating a few more parts, flanged elbow is one of this. And these couple of more parts I produced in SolidWorks just to show it to you. So that was a brief introduction about the software. Now I am going to do some demonstrative examples. As I mentioned, normally I will start from this camera body cover. I am going to start it. I will make this. Then we will produce its drawing, and ultimately we will go with assembly. So before I start SolidWorks, any question, you are welcome to ask. It's basically a lower end CAD package if we compare it with CATIA, because both SolidWorks and CATIA are from NX. And I have given you some idea. The annual license fee for SolidWorks is around 4,000. And for CATIA, it is around 18,000. So there is a reason why NX is 4 times higher than SolidWorks. It has more features. It has more capabilities. The strength of CATIA is its assembly. SolidWorks, as the number of components increases, let's say if it goes more than 100, then software start creating trouble. On the other hand, the real strength of CATIA is its assembly module. It has, but most of our assembly, for students, it is SolidWorks can easily handle, because in your case, your part can be 50, maximum 50, 40, not more than this. But that is the reason for education or for students' learning point of view, SolidWorks suits them. But if you are working on, let's say, on a new model of the car or aeroplane, then we will not recommend SolidWorks. You should go with CATIA or NX. Okay, now I'm going to start the software. The initial presentation is done. It has given you the clear idea about the software, its fee, how you can access it, and particularly about the certification. SolidWorks certification is very much popular. Employers are looking for those, particularly if you want to work freelance, then this is the must, you should go with it for freelance work. In a first lecture, Engineer Isa explained the capitalization of the CAD market. It was in billions. I know some freelance who work on these modeling packages, and they are making their living. Okay, we are going to start the software. case studies or demonstrative example. This is the first which I am going to produce this one. So this is the screen which you will see once you start the SolidWorks. Go to File, New. So once you click on New, it gives you these three options. You want to work on a part, an assembly, or a drawing. So let's go with the part. So this is the graphical user interface. Feature manager tree is there. It is the same as NX or CATIA. And these are different tabs. Feature tabs is here, sketch tab is here. This is evaluate tab, dimensional expert, render tools, and some add-ons. Task pane is here. Task pane has some libraries, some scenes, appearance, things like that. Units are here. IPS, inch, pound, second, mmgs, mks, whatever you can set it from here. And the settings are here. Options, and here is the settings. Previously, you need to set the units from here. It is here, document unit. So you need just imagine 1, 2, 3, 4 click, then you reach here. Now it is just one click and you can change the unit. mmgs, millimeter, grams, and second. As you know, first we need to create a sketch, and then that sketch we will convert into 3D model. So let's go with the sketch. Click on sketch. So it has given 3 planes. Front plane, top plane, right plane. This is another simplicity of the software. In NX, it uses X, Y, Y, Z, and ZX plane. Same is with CATIA. But in case of SolidWorks, because audience is different, so instead of X, Y, Y, Z, and ZX, they have labeled it front plane, top plane, and right side plane. So we want to work, let's say, on front plane. I want to create one rectangle. Again, with drop-down menu, you will see many options. I want to use center point rectangle. This is the origin, and I just created one rectangle. Now using smart dimension, I am going to change its dimension. 120 and 120. So I created one rectangle, I changed its dimension, exit sketch. So I made this sketch. Now I'm going to convert this sketch into a 3D using this extrude command. I am going to convert into 3D. Click on extruded boss base. And using this pointer, or directly from here, you can change its thickness. This is extrude. So if you have worked on any CAD package, you see almost the same steps we do with different package. Create a sketch, then we convert it using extrude or pad command into 3D sketch. Now, key shortcuts are very handy in SolidWorks. Control 1, front view. Control 3, side view. Control 5, top view. Control 7, isometric view. So personally, I like these shortcut: Control 1, Control 3, Control 5, and Control 7. Okay, next, we are in isometric view. We can also go from this heads up toolbar, but For me, I like these control 1, control 3, control 5, and control 7. Okay, now we are going to make another sketch. Sketch on this face. It did not change. So control 1, front view. I'm going to sketch one circle. Its diameter should be 70, so radius is 35. Once I sketch it, control 7, isometric. Exit sketch, extrude, extrude length 30. Again, another sketch. Now on this face, again control 1, another circle, radius is 30, diameter 60. And control 7. This circle which I created, I am going to basically going to make a hole. So the command which I'm going to use is extrude cut. Extrude cut. Because I use extrude cut, it automatically make the arrow in this direction, in the opposite direction. Then direction 1, click up to the last, or through all you can pick it. So we have made a cut. If I rotate it, you can see. Next, I am going to use fillet. Radius 5. First of all, on this face. So wherever there is an edge, fillet is applied there. Also, I want fillet here, fillet here, fillet here. I cannot see the fourth edge. I need to rotate it. And this edge. Control 7. Also, I want to create a fillet on the front face, but small radius. Let's say radius just 2. Just click on the face. Wherever the edges, there are 2 edges, inside and outside. So fillet will automatically be applied there. A little about heads up toolbar. It has the same commands which I'm showing, which you can see here. The views, this is glass box has appeared there. You can change the view from here. Yeah, isometric is here. But you see, let me change the scene, different kinds of the scene. Scene is here on taskbar. Basic scenes, you can. This is section. You can view the part sectionally. So this heads up toolbar, sometimes it is very useful. Zoom and unzoom is there. I mean, basic items are there. If you want to assign the material, material is here. Right click, and these are the available material. Let's assign the material copper. With one click, material is assigned. Also, let's shell it from inside, rotate it. And this is the shell. Shell thickness might be 1 milli, and I want to remove this face. So this is the shell command. Again, Control 7. We are back in the isometric view. If you want to check the mesh properties, go to the Evaluate tab and Mesh Properties. It is straightforward. Click it here and it will show you what is the density, because we have already assigned the material. So its mass, its volume, all center of gravity, moment of inertia, all mechanical properties are here in front of you. So this is the way we work. We create a sketch, then using features. And you see the history tree. It is keeping record of what you have done it so far. Now I'm going to save it. You will go File, wherever you want to save it. I want to save it on desktop, CAD week, and CAD week work here, camera body. So a simple basic part which you can understand easily we have produced. And as you know, it's steps. If we have worked on any other CAD package, 80% they are the same steps. That is the beauty of Solidworks. Now we are going to create a drawing, 3 views, isometric views, and things like that. Click on File, New, Drawing. Once you click on the drawing, because mostly we work on A4 size sheet, so there are 2 options with A4 size. One is landscape and other is portrait. Let's go with landscape. I just brought the sheet. Now here those students who have worked on CATIA, they remember 2 terms. One is edit, one is sheet, and other is sheet background. Sheet means you are working on the views. And sheet background means you are working on the title block and on the sheet, like these borders, regions, all these stuff. At any time, you can either work on the sheet or sheet background, but not both. So in SolidWorks, they have maintained the same analogy. You can either work on the sheet or on the sheet background one time, not both. So let's first of all work on the sheet background, because I do not want to see these borders, these regions. Also, the title blocks looks very clumsy. It has so many details. I want to make it simpler. Go on sheet format and right click. Edit sheet format. Sheet format means we are working on the sheet background. So you see this has been highlighted. Then right click and click on automatic border. Automatic border. Next. It has all the options. I do not want to see zones. I don't want to see columns. I don't want to see rows. Some people, they like double border line. So all these settings are here. Line thickness, from left, from right, how much margin should be there. It has all the settings. Automatic border. Okay. Now let's work on the title block. You can drag a window and can select the items. If we're dragging from top towards bottom, then those items which are between this selection, those will be selected. But in case if we're dragging from bottom to up, then those items which are intersecting, those will be selected. So these are two different selection mode. I selected from top to bottom and these items are selected. I just press delete and they are gone. I will go to the sketch. I'm going to use trim entities, trim to close it. I'm going to trim these lines. I'm going to delete these. And these lines, I can delete them. Here, so this is the way you modify your title block. It is straightforward. Let's say you are done with the title block. Right click on the sheet and click on edit sheet. Previously it was edit sheet format. Just click on edit sheet. Once you click on edit sheet, you will see this border and title block. It has become inactive. You cannot change them now. If you want to change them, you need to go edit sheet format. Okay. So now we are going to work on the views. It has the same concept as in CATIA. Same concept is there in NX, but slightly different. Go to view layout. It has only a few options. In NX, there are a lot of options. In CATIA, again, there are a lot of options, but in here you will see just a few options. Standard 3 views, model view, projected view, and auxiliary view. So standard 3 views, yes, camera body. And you will see just one click and the views are there. The front view is basically we call it principal view. If you move the front view, other view will also move along with it. Same concept as is in NX or CATIA. Click on each view. If you don't like the view, if you want to see hidden lines, you can just click it and hidden lines will be there. Now, in order to give the dimension, if you click on model view, it will just throw the dimension onto the views. And smart dimension, you give one by one individually. Let me use with model items. So once I click the model item, you will see it has thrown the dimension. Let me change it. If you don't like any dimension, because it is not according to the dimension standard, just delete it and apply it again using the smart dimension. It should come here. So you see, it's very straightforward. And this should be 30. Also, there should be center line. And one more, I applied fillet of radius 2 here. No, let me provide on the other corner. Okay, there should be a center line because it's a cylindrical part. So center line. I also want to bring an isometric view, model view. Oh, sorry, projected view is better. No, first you need to click on the view from where you want to project it. Because this is isometric, but it going out from the sheet, let me change its scale, use custom scale. Yeah. Because it is becoming a tradition nowadays in the CAD software, along with standard views, we also provide the isometric view. So you see how simple the things are here. If you want to write any note like mass, volume, or material, you just need to go annotate, note, click anywhere, whatever you want to write it, you can just write it. As far as projection symbols are concerned, by default, they are not available in NX. But you can make the symbols and add in the library, and then you can call them. Or you can simply sketch it manually here. Now this is your work. You want to save your work, preferably in PDF format. But first, let me save this one. File, save as. It's drawing file, Solidworks drawing. Okay, I want to save it in PDF also. Save as. Directly, you can save in PDF. Previously, this option was not available. PDF and camera body. Let's check it out. CAD week and This is PDF. So this is your neat and clean drawing sheet, which we have just created. So you see, you can do the same things in NX in CATIA, but there are a lot of other options are there. I think it is good because you as a student, it gives you opportunity to explore more items. Okay, this was the drawing. Meanwhile, if you have any question before I move towards the next, you can ask. Any question? What is this? Because I am already joined it. Okay, students. Next, I am going to start with assembly. Let me see if there is any students, any question? Because I feel I am going a bit fast because I need to cover so many things. But still, if you have any question, you are welcome to ask. Yes, please.
How to the
Actually, your voice is not clear. Can you please type your question or can you speak again?
Yes, Doctor. Can you hear me well?
Yeah, now it is much better.
Yes, Doctor. Asking about how to download Solidworks because I want to use it.
Yeah, you should use it. If you are from UAEU, I strongly recommend to use it.
How to download it?
I have given, I have mentioned it in my slide, my.solidworks.com. Go on this website. You can use cloud-based.
Is it free?
If you want to download solidworks.com, directly go there and you can download it from there. Solidworks.com. I strongly recommend my UAEU students because they have already worked in CATIA or in NX. These two are high-end package. SolidWorks is a lower end package. So for them switching to SolidWorks, it will be like a breeze. You see, the interface is simple, no clumsy, only a few icons which do the job. And you are already familiar, I'm very much sure, with all these icons. If you have time, please think about certification. That is another advantage to you from the other students, from the other graduate who will be in the market. $99 is very reasonable fee. At least associate level certification you should go. By any means, I have no affiliation with SolidWorks. Just for your betterment, I am recommending this. Okay, now we are going towards the assembly module. I will create 3 simple parts. Again, the same part which I use in my NX classes so that you can clearly relate them how easier it is in the SolidWorks. First of all, I will go with bottom-up approach. I will create 3 parts: bottom plate, top plate, and then collar, and then I am going to assemble them. Simple parts I will make it. So I created a file. I am going to make sketch. It should be in millimeter. See, the change of unit is directly here. Otherwise, you will forget. On top plane, I am going to open a sketch, centered rectangle, 120 by 120. Exit sketch, extrude, let's say 30. No, 20 should be good enough. Now again, I am going to open a sketch on the top face, Control 8, Control 1 front, Control 3 side, Control 5 top view, Control 7 isometric, Control 8. It makes the view perpendicular to the screen. Control 8. So these are shortcuts. I really love these shortcuts. I'm going to sketch one circle. Radius should be 10. And using smart dimension, I am going to constrain the center of the circle, this distance, to be as 20. Again, smart dimension, the vertical distance. Sorry. This should be 60. Okay. Exit sketch. Control 7 isometric, and I am going to extrude it. Might be 60, 70, whatever you like it. Now I am going to mirror it. This is mirror. Yes, mirror feature. So yes, I mirrored it. See, it is straightforward. Let me label it bottom plate. Now I'm going to create the top plate. Let me delete these last 2 steps. I'm going to delete this mirror. And I am also going to delete this boss extrude. I have a sketch. I am going to use Extrude Cut. This is the sketch. Simply through all. And now I'm going to use mirror this one. So just mirror feature, I use it and I created these 2 parts. I'm going to save it as top plate. Okay, now I'm going to create 3rd part. Again, sketch will be on top plane. I'm going to sketch one circle. I mean, it's again units. This is very much easier. Really, I love this feature. So let's do it again. This is the circle. Do and start it again. Circle. Radius 10. 20 and another circle radius 15, mean diameter 30. I just created these two circles. Control 7, isometric. Extrude. No, it is not picking the first circle because I changed the unit. Let me create it again. New part and units. Sketch on the top plane, one circle, radius 10, another circle, radius 50. I just created these two circles, exit sketch, control 7, isometric, and then extrude, might be 30, should be good enough, or even 25 should be good enough. Control 7. I'm going to apply the what we call chamfer or fillet. Let's apply fillet. Fillet and chamfer both are here. Chamfer 1 milli and angle is 45 degree. First of all, on this face, because there are two edges, the fillet is applied. Then I am going to rotate it. Again, fillet, chamfer, bottom face, and applied it. Control 7, and this is the collar which I have just created. Save as collar. Okay, we have three parts. Now I'm going to work on an assembly file. Insert component, browse. First of all, bottom plate. See only a few items in the assembly tab. Unlike the NX or CATIA, it has a lot of items. Again, insert component, browse, top plate, insert, now this time collar, and again, so we have these four parts. Control 7, it will fit there. And now we are going to apply assembly constraints. As I mentioned in SolidWorks, these constraints are known as mate. Click on mate. There are different kinds of constraint. The first one is a regular mate, then advanced mate, mechanical mate. If there is mechanical mates means screw mate, gear, slot, cam, different kinds of mates. Universal joint is there. So these are different kinds of mates available in SolidWorks. Let's go on the standard mate. First of all, coincident. Rather, we should go concentric first. Concentric. Concentric means center of this and center of this should be the same. You see? And now I can use, this is concentric. Both are in the same center. I applied concentric mate here. Now I want the collar, bottom of the collar, to touch the top part of the plate. Made coincident this time. This one, Control-7, and this one. You see it has. Similarly, I'm going to bring the second collar. Made concentric. This with this one. Okay. Again, I'm going to rotate it. I am going to zoom it. Made coincident between this Control-7 and this. And now I want to bring this top plate here on top of these collars. Made concentric. This with this. You see it has come there. The bottom of the plate should touch the top of the collars. Made. Let me rotate it first. Made coincident Control-7. And because it's a rectangular part, I need 3 degrees of freedom. So let me have one more, let's say parallel, this side with this side. These two sides should be parallel. So all the mates are here. It is showing you all the mates. So this is assembly. You see how simple it is. Exploded view is here. You manually create, for example, if you click here, there are 2 options, translate and rotate, and second is the radial step. Let's say translate and rotate. You click it here and tryout appears, and then you can move. Manually you explode them. Again. Bill of material is here. If you want to bring it here, directly click it here and you will see you can have the bill of material. If you want to bring it in a drawing sheet, you can do it easily without any problem. Let me also show you in the drawing sheet. But first, let me save this one. OK, one more thing. How to save your assembly work? And next, it is slightly tricky. Sorry, in Solidworks. Because it is exploded view. This pack and go. That you are going to use here in assembly drawing. If you simply click save, it will save the assembly mates, these mates. coincident, these only this it will save. It will not save the individual part file. You want the assembly file, individual part file, and assembly mate. Then you have to click pack and go. With pack and go, it saves everything. See, it is showing me this assembly file, bottom plate, collar, top plate. This you want to save it. If you have created drawing, you can also include all this. And this is the folder. You can save it as zip file, or you can save it, in a folder. This is really nice feature. I like it. Pack and go. It is going to save in documents because already file there. So, and now if you want to create its a drawing view, easily you can create it. Its name is assembly 2. I would like to go with portrait. My document. Where is the assembly file? Let me check. Let me save this again. File, pack and go. I want to save it on desktop. Okay. Let's check on desktop. Let me try this option. It is giving me a hard time in saving. I don't know what's the reason. So this is the sheet. Edit sheet format. I can format the sheet, and it has shown all the views. All the views which I want. Or let me go from here, model view, assembly. Okay, so it has come there. Now I need to look for bill of material, auto balloons, or I can create it manually. So this is the way we create the drawing sheet. assembly drawing with bill of material, with balloons. All these details are here. You can save it as your PDF and some other parts. Its interface is user friendly. Interface is much easier as compared to other high-end CAD package. Yes, your questions, please. Your question, students. I am here to answer your question. I tried to keep the things as simple as I can. I can go with the complex part, but in that case, you might lose the interest. The things which you can see, which you can understand clearly, I kept the discussion only to those points. But do not take it that you can only make these simple parts. No. Complex part. I mean, complex assemblies you can create in SolidWorks. It is just your imagination or your competency, how deep you dig inside or go to the package. Again, if you have time, my sincere advice is to consider this certification. It will add value to you once you will be graduate and looking for the job. This certification definitely will be a plus point for you. Rashid, SolidWorks has its own strength, NX has its own strength. Personally, I like NX because NX you can do many things. Its interface is neat and clean, but SolidWorks has some very attractive features, very charming features. Though it is low end, it is up to you. It's a matter of taste. You like SolidWorks or you like NX or you like CATIA, it is simply up to you. I have worked on all these three packages, so for me, all three are the same. Once I started the university, at that time, they were using SolidWorks. Then they switched to CATIA, and then they switched to NX. So even before joining the university, I was working with NX. At that time, it was known as Unigraphics. So I have worked on fairly good number of software packages. So, I mean, it is up to you how you go. Interface of SolidWorks is simpler, easier, attractive. I should use the word attractive. This is the same term which SolidWorks use in their marketing. Yes, Khalid, because SolidWorks is lower end, it has only a few items which you need to use. NX is high end. It has a lot of options there. Sometimes we do not use all these options, but the options are there. At this stage, while we are approaching towards the end of the semester, I recommend to concentrate on your studies. One semester will be over. Normally we have 2 weeks or 3 weeks break. So during that break, if you can utilize some time to learn SolidWorks, that will be great. Even if you do not go for certification, just learning a new tool, go for it. There are many tutorials, many books online, many webs, videos, tons of materials are available. Guys, any further question? Again, I would like to thank ASME. Yes, please.
Can you explain the competition for students?
Okay. For competition, cantilever you are going to design. You are free to use any design, any imaginations, but you should use pattern command in the cantilever. So make one basic design and then use circular pattern or linear pattern, whatever you like it, to make the design which you like it. Keep it simple, keep it attractive. The timing of the competition, the ASME organizer, that will help you about the timings. But the product, I have explained it to you. You can think about it.
Engineer Haider, I think it will be starting from today, and they have till Thursday.
You can check with the organizers. I'm sorry, because regular classes are also going on. So for us, it is difficult to keep track of these things. And above all, you know, the Abbott reviewer, they are also reviewing the things these days. So we are extremely busy these days. So I'm sorry, you can check with organizers. Just send them an email and they will reply. Midterm exams, ASME, Abbott reviewer. So many things are going on these days. Yes, guys, any further question? I would like to thank you for your participation. If anybody needs the presentation which I have prepared, you are welcome to contact me and I can forward it to you. Or anything regarding the software, if you need any help, any point, just send me an email. I will be more than happy to guide you. Thank you. Inshallah, we will see you again in the next week in the campus. Assalamu alaikum. Please do participate in this survey. It will help us to improve. If we offer next ASME CAD week, it will be very helpful for us. So all participants are requested to take part in this survey. Assalamu alaikum.